Now, how can we, I mean, you know, it works with the formula. How can we actually show that this is true? Okay, let me try and illustrate it for you, right? So you might have noticed this is not exactly the same example I showed you yesterday. It's off just by a little bit, right? So let's try and draw this thing, okay? I want to try and visually, that's why I call this an illustration. I want to try and visually demonstrate that this is true, okay? So what I want to think of is all of these as areas, okay? Yeah, okay, right, thank you, spoilers. Let's take that one. I want to draw that as a square, which is 1 by 1 in dimensions, okay? So this square, that represents my first term, okay? Now, how would I draw the rest of the terms? I'm just going to imagine that there's another square here with the same dimensions, okay? If I wanted an area of a half, how could I figure that out? How could I put that in, right? Well, I can take this imaginary square. I could do a triangle, actually.
But that would work. We do that for fun.
Sure, why not? Okay, let's do a triangle.
We are crazy.
There you go. So this here, this part here, right? This has an area 1. This triangle has an area of a half. Okay? All right, now I want the next term, which is a quarter. So this leftover imaginary triangle, I can get a quarter out of it by dividing it in half again. Right? So I'll do this one.
Yay.
So that one is a quarter. Yes? Agreed? Now where do I get an eighth? I can draw it anywhere I like, I suppose. This one is an eighth. Okay? The next one will be a 16th, even though I haven't written it. So this imaginary triangle was an eighth. So if I halve it again, this way. This way?
Yes.
That way. That's a 16th. Okay, do you need more of a proof? How far do I need to go? That's going to be 1 on 32. You can see, as n approaches infinity, I'm approaching something. What am I approaching? A rectangle, which is 1 unit by 2 units. Hence my answer. Okay? So, I mean, that's not a proof. Though there is actually a book. It's called Proof Without Words. You can go look it up. It's filled with stuff like this, just diagrams, and there's no explanation attached to it. They just like deal with it. Okay. Right now, those of you who were here yesterday, has anyone come up with an answer yet? Anyone come with a joint?
To divide it into 3.
Divide into 3.
Wasn't it the answer was also?
Okay, right. So for those of you who weren't here yesterday, I took this series. I left off the 1, right? So you can see that if I left off the 1, the difference would be I'm just looking at this cut up square at the bottom. Okay. Now the ratio here is a half. We were experimenting with what happens if the ratio is minus a half. Okay, and you still start at this point. Okay. Now using this formula, you can go ahead and verify it. We found that the sum would be a third. Okay. We found that a half minus a quarter plus an eighth minus a 16th and so on was going to be equal to a third. And I said, can you draw this just like we have drawn this? Okay, any takers? Any takers?
Could we try it out? Or
I just gave you a few minutes to try it out.
Did you?
What?
Wait, where were the few minutes?
While I was, because you already knew all of that stuff before. Never mind. I'm gonna give it a go because I'm running out of time. Okay. Now here's the series. Okay, just to make things a little clearer, I'm gonna write a bit more of it. Okay. I'm gonna keep going. What's the next term? 1 on 32. 1 on 64. That should be enough. Now we're contending that it's equal to a third. Okay. Now to try and make this a little clearer, right? I think the thing that throws us off is the negatives, right? If I were to do it with this, I'd have to have like, you know, areas and then negative areas. That's a bit off, right? So instead, I'm going to try and account for the negatives in a way which doesn't have negatives in it.
Draw another square and say we're going to take this one away.
We'll have a square in a second, but how am I going to get rid of all these negatives? Well, it just so happens that every negative here, in every negative term in the series, can you see, is matched up to another term which is positive but bigger. You see that? For example, a quarter minus a quarter and a half. I can match them up together, right? And this negative and this a half, together they're going to be a positive. Yes? What are they, by the way? It's just a quarter. Okay, in the same way I can keep pairing up. There's a pair here. What are they going to be equal to? A 16. Right? That's what I meant to say. Right? Now, what might the next one be? Okay, now hold on a second. Okay, you're following. Are you following? That's right. I've got a new series. This time, the first term is a quarter, and the ratio is also a quarter. Okay, now this I can draw. Let's have a go. Okay, I'm going to go back to my square because squares are easy to divide up into quarters. Okay, so that's a very rectangular square. Oh well. Okay. Yeah. All right. Help me out here. Now, how am I going to draw quarters out of this? Well, I'll just put some imaginary lines here. Okay, so where's my first quarter going to be? I can pick any of them, right? Let's do the top left. Okay, so there you go. There's a quarter, okay? Now the next thing I want to have is a 16th. That's a quarter of a quarter, right? So which way will I go? Well, I could go anywhere.
Bottom rightmost.
I think this is probably going to be the most helpful place to do it. So again, I'm going to divide it up. And there is, so I should have done the lines in the same direction, it doesn't matter. There's a 16th. Where is 1/64th?
Keep going in the same
I'm going to do it again, right?
Yes, and then it's in 3.
Okay, now can you see what's happening? Can you see what's happening? What's going on? Can you see the third? Can you see the third? For every area that I have shaded, I have 2 that are exactly the same size, which are not shaded. That's 1/3 of this area. And this is 1/3 of this area. And this is 1/3 of this area. So if I do that as n approaches infinity, the whole thing ought to be equal to 1/3. Okay, you can even see it's sort of like I'm dividing up into an equal sort of section. Okay, so it took me a little while of staring at it. I did actually try something with negatives, but it started getting confusing. So I think this sort of makes sense of it. Okay. And do you ever need to do that? Not really, but I just wanted to show you that the numbers, these numbers, they actually mean something. It's not like something you just spit out a formula and who cares. Okay.